This is Kara, and she's a robot dog that I've been building over the past year. Kara is the fourth robot dog that I've built, and she is easily the most dynamic and most well designed. What makes Kara particularly special is that her joints aren't driven by gears or pulleys. They're driven by rope. Specifically, they're driven by capstan drives. In fact, the name Kara is an acronym that stands for capstans are really awesome. Now, what the heck is a capstan drive? And why did I choose to use that to build Kara? And how did I build Kara? Well, to answer all of those questions, we have to start from the very beginning.
Blah, 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 blah. Not the very beginning. There we go. About a year ago, I started this project with a video on capstan drives, which you should definitely check out for all the theory, design, and testing details. Essentially, a capstan drive is a rope-driven speed reducer. Imagine two gears, but without the teeth. So now, they're just drums. And instead of using teeth to transmit torque, we have tensioned rope wrapped around the drums. And not just any ordinary rope, but a rope called Dyneema DM20, which has a creep rate of essentially 0, meaning that it won't stretch over time when you put it in tension. The main benefit of a capstan drive is that it has virtually zero backlash, or zero play, which makes it super precise. A capstan drive also has low noise and low cost, and all of these benefits make it a great option for robotics. In fact, I even demonstrated this with two robot dog test legs, one that was a 5-bar linkage, which could also draw shapes, and one that looked a lot more like an actual dog leg. There was also a lingering issue that I ran into during this project, which I've since fixed. Basically, I couldn't get a perfect 8:1 gear ratio on any of the capstan drives, and as many comments correctly pointed out, the problem was that I was calculating the gear ratios using the outer diameters of the drums when I should have been using the effective diameters of the drum.